Welcome to AI Frontiers. Today's episode explores robotics revolution, AI-powered machines in action, synthesizing 10 papers from October 25, 2025. Cutting-edge advancements in robotics through AI integration are examined, with a focus on real-world applications and innovations. This content is presented by AI Frontiers. This presentation provides an overview of today's robotics research. Imagine robots navigating hospitals or disaster zones with human-like smarts. The themes, findings, and future of 10 recent papers are explored. An engaging narrative blends technical insights with real-world impact, highlighting how AI makes robots safer and more adaptive. Machines are evolving as true human partners in this journey. A broader look at the field is set. Computer science robotics blends computer science and engineering to create machines that sense, decide, and act in the physical world. Key elements include perception via sensors like cameras and lidars, decision-making with AI models, and physical actions such as grasping or navigating. Applications span healthcare for precise surgeries, manufacturing for efficient assembly, and exploration with drones in remote environments. Challenges involve adapting to unpredictable settings and ensuring safe human interactions. Yee's 2025 papers advance AI for smarter, ethical robots integrated into daily life. Overarching research themes from the 10 papers are explored, distilled into key areas. First, benchmarking and standardization in robot navigation is a critical focus. Consistent benchmarks for social robot navigation are emphasized, addressing the lack of unified metrics. Chetri et al. 2025 highlight needs for measures like path efficiency and human comfort, pointing out inconsistencies that lead to unreliable comparisons. This theme overlaps with real-world testing, incorporating human surveys to gauge subjective factors such as trust. Fragmentation in evaluations is addressed, promoting reliable comparisons and driving progress towards standardized, safe human-robot interactions. The second theme involves advanced control frameworks for high-dimensional systems. Complexity in managing robots in chaotic or uncertain environments is addressed, focusing on stabilizing systems with many variables, like multi-joint robot arms in noisy settings. Labov-Konecki et al. 2025 introduce a multi-timescale hierarchical reinforcement learning approach that handles stochastic dynamics in hyperchaotic systems and robotic manipulators. Reinforcement learning trains agents via rewards and penalties layered here for stability. This ties into vehicle control, as in Hosseini Miangole et al. 2025, where vision language models enhance adaptive responses like lane keeping. Robustness is enhanced in chaotic settings such as turbulent flights. Building on advanced control frameworks, hierarchical approaches are extended for stochastic dynamics in manipulators. Traditional methods are outperformed in error reduction and convergence speed. Multimodal data is integrated for better decision-making, paving the way for reliable autonomous systems in industries. One pivotal study shows 50% better disturbance rejection, ensuring stability amid noise and enabling applications in turbulent environments like factory workflows or drone operations. The third theme covers multimodal perception and decision-making. Diverse data sources, vision, language, lidar, are integrated for smarter robot behaviors. Robots understand and reason beyond mere seeing. Kien et al. 2025 exemplify this with a neuro-symbolic framework for UAV landing in cluttered areas, combining neural perception with symbolic logic for verifiable decisions. Neuro-symbolic reasoning merges neural pattern recognition with logical rules for transparency. This supports sim-to-real transfer and lifelong learning in flexible robotics. Wang et al. 2025 use spatiotemporal neural networks to estimate continuum robot shapes under external loads, enabling precise manipulation. Key findings from the papers are highlighted, representing groundbreaking insights. Multi-timescale reinforcement learning stabilizes systems with low errors, such as an integral absolute error of just 3.912 in high-dimensional cases, as shown by Labaf-Kaniki et al., 2025. Dynamic-aware mapping filters moving objects for accurate navigation, achieving errors below 5 centimeters in dynamic scenes, per Chen et al., 2025. Neuro-symbolic methods boost UAV safety and interpretability, offering human-readable justifications, according to Kien et al., 2025. Action guidance improves manipulation stability, reducing failures in tasks like assembly, as in Park et al., 2025. Co-design optimizes humanoid recovery from falls, mimicking human reflexes for quicker, energy-efficient responses, from Yue et al., 2025. These signal a shift toward robust, adaptable robotics. Methodologies employed in these papers are examined, featuring a toolkit of techniques. Reinforcement learning, often hierarchical, optimizes policies in uncertain environments through rewards. Strengths lie in adaptability, though computational demands and sim-to-real gaps pose limitations. Multimodal fusion integrates sensors for rich context, providing accuracy but sensitivity to noise. Neuro-symbolic reasoning ensures interpretable decisions by merging neural and symbolic elements, fostering trust, yet requiring expert rules and facing real-time computation challenges. Benchmarking via metrics and surveys standardizes evaluation, promoting reproducibility while risking biases from inconsistent standards. Combinations, such as fusing reinforcement learning with perception, mitigate weaknesses for effective real-world use. 3 influential papers are delved into, starting with Chetri et al., 2025, titled A Short Methodological Review on Social Robot Navigation Benchmarking. This paper is selected for its foundational push towards standardized metrics, impacting social robotics. Novelty is found in exposing evaluation gaps and promoting human-centric benchmarks. It represents a key direction in reproducible ethical robot-human interactions. With high influence potential for unifying fragmented research efforts, the objective addresses the absence of standardization in navigating human-filled spaces, surveying trends from 2020 to 2025 through a systematic review of 85 papers, analyzing metrics, algorithms, evaluations, and conclusions. The second selected paper is Labaf-Kaniki et al., 2025, titled A Novel Multi-Timescale Stability-Preserving Hierarchical Reinforcement Learning Controller Framework for Adaptive Control in High-Dimensional Dynamical Systems. It is chosen for advancing control in complex systems with proven stability gains. The innovative multi-timescale approach handles noise and high dimensions effectively, exemplifying directions toward robust AI for chaotic real-world applications. Significant impact is anticipated on fields like autonomous vehicles and manipulators. The framework, based on semi-Markov decision processes, features high-level and low-level policies with Lyapunov constraints tested on hyperchaotic systems and manipulators, achieving superior error reduction and robustness. The third selected paper is Qian et al., 2025, titled Bridging Perception and Reasoning, Dual Pipeline Neuro-Symbolic Landing for UAVs in Cluttered Environments. It is selected for pioneering interpretable perception in UAVs, enhancing safety. The novel hybrid method bridges neural and symbolic elements for verifiable decisions, representing trends and explainable AI for high-stakes tasks like rescue. Broad representativeness is noted in multimodal robotics advancements. The neuro-synland method uses dual pipelines for offline knowledge generation and online reasoning, tested on datasets and real UAVs, yielding superior accuracy, robustness, and interpretability. Future directions in robotics research are considered. Foundation models are to be integrated for natural human-robot communication. Lifelong learning is advanced for continuous adaptation in new environments. Co-design matures for task-specific robot morphologies inspired by biomechanics. Sin-to-real gaps are addressed with improved simulators and ethical frameworks to mitigate biases. Efficiency, privacy, and standardization are focused on to build trust. Tackling challenges like computational demands and ensuring equitable decision-making in diverse contexts. The synthesis and review process for this deck is outlined. The synthesis was created using AI tools, including GPT-Grok with model Grok 4709. TTS synthesis was handled via OpenAI for audio elements. Image generation utilized Google tools for visuals. Content underwent review by a human expert. Note that some oversights may exist, with all references provided for verification. Subscribe to the YouTube channel for more cutting-edge AI insights. The channel title is AI Frontiers. Join for daily dives into AI and robotics research. Hit subscribe and turn on notifications today. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.